Hello, everyone, and welcome to my session. I'm Viktoria Ondrejova, and today I will take you from zero to Superset Hero. So, a little bit about myself. I'm currently pursuing a master's degree in computer science at Comenius University here in Bratislava, with focus to artificial intelligence and natural language processing. Also, a data analyst here in Slido, and I started working in Slido last year in the marketing team, actually. But over the time, I became a data analyst as I have a background in data science as well. So in Slido, the Superset is our main data tool. We use it for any visualization or executing queries. So as I onboarded for the data analyst role, I became really familiar with it and noticed some pros and cons about it. We all love Superset because of how open source it is for its scalability and active community. But after some time, you get to know the ugly and rather impractical sides as well. For example, you get to notice that it's awfully painful to do a mass modification in Superset. And I was actually texting with my colleague Alinka about how we renamed one column in our database, and now she has to go and update all the charts, and it's taking her ages. So for example, let's say we rename the column first name to a column like just a name. And even this small change means that we need to check and adjust every chart that references this column. For Alinka, for example, this means that she needs to open Superset, wait for it to load, then actually find the chart she needs to modify, open the chart and wait for the chart to load, and find all the occurrences of the column she has to rename, actually rename the columns and click on save. And you can see now we have to update the chart, which also takes some time. And finally, the process is done. And we saw that even this small change requires a lot of time and clicking. And this was only one chart with one modification. And as let's say we need to modify 50, hundreds, or in the worst case scenario, more than 10,000 charts, because that's the number of charts we have in our superset. It would take an army of people to do so. But there is no other way, no easier way to do that. So we can just support Alinka and with the message that sucks. Other two downsides are reviews and versioning. Nowadays, the only way to have something checked in Superset is to message your colleague about it, as I'm doing right here. And because there is no actual system for reviews, as for example, there is one in Git. And the same goes for versioning. You actually can see the history of modification in the actual Superset. And the last negative that I will focus on today is complicating migration of charts and dashboards to a new server. So again, I received a message from our legal guy, Maros, about migrating some data to the US server. And in our case, we have all the servers here in Europe, but the clients want to have data in the US. So you start to devise those data and want to analyze it and visualize it, but all your visualizations are in the European superset on the European servers. So in that case, all the dashboards and datasets which created need to be actually created all over again from scratch in the American superset. And that's actually a lot of work for us, so we just left him on red. So here we are in this situation where we don't want to get rid of the superset, just enhance it a bit and make it more efficient. And this is exactly where the superset meets Terraform. So as we started to play with the idea of how we could fix the problems we experienced with Superset, we looked closely at the Superset API. So when we were figuring out the structure of the JSON, for example, our dataset, and how to actually write a JSON in that way, we needed to kind of reverse engineer it. So first we made a chart or dataset in the actual superset. Then we went to the Superset API, and with the get function, we we called the chart or dataset we wanted to see with its ID. And from this messy output, we then wrote the shortest JSON possible to get the chart we actually wanted. So with this approach, we obtained the following JSONs. For a dataset, the JSON needs to contain the database ID, the schema, the query, if it's a virtual dataset, and the dataset's name. For chart, it's a bit more complicated, as we can see, and JSON needs to have specified the data source ID and the type. Then params, which is another nested JSON with all the filters and metrics that are needed in order to create a chart. And lastly, the chart's name and type. So with it done, when we get familiar with the JSON, we've decided to pair it with Terraform, which is a tool that is mostly commonly used for infrastructure management in a so-called infrastructure as a code manner. You actually write a few config files representing your infrastructure resources, some servers, databases, and access rights, and then simply run Terraform apply in your terminal, and Terraform will create everything for you in your cloud. So this saves you a lot of clicking and errors in the cloud console. So instead of simply using the JSON I've shown earlier, the Terraform has some advantages as foreign keys that helps us to link datasets with charts together. Also, it does much of the background work for us, so we just need to define the structure of our config files and the actual CRUD functions. But one downside for me is that Terraform is written in Go language, which at that time I had literally zero experience with it, but it's kind of similar to a C language. So our defined structures of datasets and charts in the config files are very similar to our JSONs we previously saw. So for datasets, it's basically the same. Yeah, we just define the database ID, again, the schema, the dataset's name, and the final query if it's a virtual dataset. And for charts, it's a bit more complex, as we can see, but still very similar to the JSON. In chart, we need to define the chart's name and data source type. Actually, the actual type of the chart, which is in our case a bar chart. And here for the data source ID, we will use the Terraform's advantage of foreign keys and linked it to our previously created dataset in the Terraform. These foreign keys are really such a huge advantage of Terraform, as we can easily look up the dependencies or the children of our dataset later. Next thing are metrics, where we have represented them with string array, and the group bys, or the dimensions in the superset, the filters for where and having. We have also defined the time grain for this chart and an x-axis. Okay, so with that done, it's finally time for a demo. So here we are in our Go ID, and we are going to create two datasets, one physical without the SQL query and one virtual one with the query. So as you can see, they're literally the same structure as I showed earlier. One without the query is the physical dataset, and with the query is the virtual one. So with that done, we just simply need to go to console and type Terraform apply there. Hit enter, and as you can see, the Terraform is adding two datasets. Here is our virtual one, and here's our physical one. And we need to confirm the change with a yes. And we got the message that shows us the apply was complete, and we added two things to our superset. Just to be sure, we can check it in the actual superset, and here we have our physical dataset and the virtual one. So great, now onto the charts. And our goal is to create this simple looking chart that has all these parameters filled out. So back to our project, we will define the chart structure. It's all, again, just the same structure with the parameters filled out as we had earlier. And with that done, we just need to go to the terminal and type Terraform apply there. Hit enter, and we can again check if the Terraform understood the request, and you can see it looks like it did. We are adding one chart to our superset. Again, we need to confirm the changes with yes. And again, we got the message that the apply was complete, and we added one chart to our superset. Finally, we can just check the actual superset at the end. The chart has all the parameters filled out as we wanted. And I know this Terraform files looks kind of scary, because why would you want to write a code if you can just kind of clicked out a whole the chart and just see it right before you? But the project is mainly for people that need to maintain the superset as a whole. If you need to just create a chart like this, it's really easier for you just to click it in the actual superset, and maybe then just download it to the Terraform file, which I will show later. Okay, so this project solves a lot of problems for us that we previously had with Superset. So remember the message about renaming a column that takes Alinka 3 days. So let's look how we can help her with our project with that. So we are back in the Terraform project. We have here the data set, which column we want to rename, and the chart that is actually children or dependent on this data set. So firstly, we just rename these columns in the SQL. And then we just need to look up all the charts that have these dependencies through this ID, and find the old column name and just retype it to the new name. And basically that's it. We just need to again type Terraform apply to our terminal and check the modifications if they are correct. So we can see like we renamed or updated the name, and we changed the query here in the dataset. Again, just confirm it by yes. And we get the message that we are going to change two things. And just to be completely safe, we can also just check the chart in the superset. As we could see, it really did change the name to the first name. So with that, we solved the painful mass modification problem we had with our superset. And the next problem we want to tackle is the reviews and history of our charts. To avoid the awkward search for people that modified my chart and asking reviews on it, with Terraform, this can all be solved by just simply putting the config files into Git. And that way we can request the reviews by creating a pull request and easily see the file's history. We can also automate this even further by creating pipelines for the Terraform apply command, which will be executed after a successful merge. Great, so that way our project solved another two problems we had, the reviews and the versioning. Lastly, we just need to look at the complicated migration. So actually now we don't have to ignore the message from our legal guy here, as there is no longer a need to create everything from scratch on the new servers. With the Terraform, if we have our charts written in the config files, we just need to execute the Terraform apply on another server. But what if we don't have the structure of the data charts, or we've created some charts, like I mentioned earlier, and now just want to download it to the Terraform files? This simply means for us, we need to import the structures to our Terraform. We can do that by, again, going to our Terraform project in the main or the Terraform file. Then we create an empty structure for it. In this case, we are going to import a dataset. And in the terminal, we just type Terraform import, and the name of the empty structure we just created, and the ID of the dataset we want to import from Superset. Hit enter, and we can see the structure was imported to the state, which is kind of like a memory in a Terraform. And to get the structure, we just need to simply need to type tf add state full. Enter that, and now we have obtained our dataset and its structure, and you can just now copy paste it to your Terraform file. Ideally, this would be done in some script, so you don't have to go and create an empty structure for all the things you want to import. So this can be also automated even further. So as you could see, our program tackled even the last problem easily. And this project is mostly for data analysts that needs to maintain the charts in the Superset, as it can help you stay more organized and maintain a better order in your data. So in the end, I want to pinpoint that I started this project with zero experience with Terraform and with the Go language, but as the ChatGPT said, and I can't stress this enough, the only prerequisite for greatness is a willingness to Google.